Suppose you give a model a hard problem, a floor sum. You watch it work, step by step, fluent, completely sure of itself, and the answer it lands on is wrong. You've seen this. So you do the obvious thing, you ask again. It gives you a different answer. Ask again, different again. It never gives you the same answer twice, which is strange. Why would a machine give a different answer every time you ask the same question? Here's why. The model doesn't look up an answer. It builds one token at a time, and at every step, it's picking from a handful of options. So every run is a different walk, and it ends somewhere different. The model doesn't have an answer. Each run is one draw from a whole cloud of possible endings. Look closer at where they land. This is the future field. The answer it lands on almost never sits on 532. The mass piles up in a whole family of wrong answers. So why not just brute force it? It does land on the truth once in a while. So keep sampling 1,000 times, 1,000,000. Surely the right answer turns up eventually. Honestly, yes. In a trivial sense that immediately collapses into no. Here's the mechanism. To choose each next token, the model ranks every possible word. Then under its sampler, it keeps only the top handful, about 10, and discards the rest. Their probability becomes exactly 0. And a word with 0 probability can never be drawn. Not in 1,000 tries, not in infinitely many. Chain that over every step, and most endings aren't unlikely. They're impossible, so the real question was never whether the right answer exists somewhere. It's whether this process, from where it already is, can still reach it. So far, we've only ever restarted from the beginning, asking what the model can do in general. But reachability isn't a fact about the model, or even the question. It's a fact about where the run already is. So here's the move. Take one run and pause it partway through. Everything written so far, the history up to this point, call it the prefix. Now ask a different question, not could this model ever answer, but this, from this exact half-finished thought, what futures are still available. Let it finish from here, again and again. Count how many still reach the truth. That fraction is the reach. We never opened the model, we only watched where it goes from here. Because the model isn't just choosing an answer, it's walking through a space of futures, and the question isn't only whether the right future exists, it's whether the path it's on can still reach it. Before we sweep this across the whole reasoning, predict something. As we freeze later and later, as it commits to more, what happens to reach? You'd probably expect a smooth decline. Lots of room early, slowly closing, a gentle slope. Hold that picture, we're going to test it. To test your guess, we just repeat the operation everywhere. Freeze early, sample a few hundred futures, measure reach. Then move the freeze line deeper, sample again, measure again. Step it all the way through the reasoning, asking the same question at every position. From here, can the right answer still be reached? Each answer is one dot. String them together and the dots become a curve. Remember your gentle slope. Here's what actually shows up. For a while, reach holds. The truth is well within reach. And then it doesn't fade. It falls off a cliff. In the span of a few tokens, the fraction of futures that reach the right answer collapses to nearly nothing. And it stays there. That collapse, target reach falling and staying down, has a name. This is answer foreclosure. Not impossible, but foreclosed. Unreachable from here under this sampler. Sample 1,000 more times from past that edge. Almost none of them find it. The answer didn't get gradually less like it dropped out of reach. And here's the part that should bother you. That cliff comes early and the model keeps writing. It keeps reasoning in fluent, careful, confident sentences for a long stretch, often a couple hundred more tokens, before it ever states its wrong answer. So there are two clocks running. One is when the answer gets settled, the other is when the answer gets spoken. They are not the same clock. By the time you read the conclusion, the outcome was decided long before. while the words on screen were still performing the act of working it out. That is the sense in which the reasoning was theater. The visible performance kept going after the reachable answer had already collapsed. There's a precise name for that moment, commitment before expression. To be clear, we're not claiming the model wasn't really thinking. We can't see inside, and we're not trying to. We're saying something narrower and stranger. The performance continued long after the answer was, behaviorally, already settled. So if the cliff is this sharp, why hasn't it been obvious? Because of how we usually look. Take many reasoning paths and average them together, and something sneaky happens. Each one falls off its own cliff, but at a different place. Average 100 sharp cliffs scattered across different moments, and they smear into exactly the gentle slope you predicted at the start. That smooth curve was never the experience of any single path. It's an artifact of averaging. The cliff was always there, the average hid it. Now we can name what you've been watching. The right answer may still exist in the broader space of possible completions or reachable from an earlier point in the reasoning. But from this committed path, under this sampler, it is no longer reachable in practice. Existing and being reachable are not the same thing. Existence is not reachability. What we watched, the answer foreclosing, is existence and reachability coming apart. Put more plainly, what a model can do is not the same as what it will do. If you've ever played chess, you already know this feeling. A game can be lost long before checkmate appears on the board. The position is decided, while there are still plenty of legal moves, pieces still sliding around. Watch the line of play. The instant this piece lands, the net is closed, the game is decided. Yet the pieces keep sliding, perfectly legal moves on both sides, and only several moves later does checkmate finally appear. It was settled long before it surfaced. Like that game, the model's answer was settled long before it surfaced. No opponent, no scoreboard, just a position already decided before it's spoken. Now the honest limits, because they matter. This was measured on a particular model, a particular kind of problem, a particular declared way of sampling. Change any of those and the picture can change. Out of reach means out of reach under this instrument in a finite number of tries. Not gone forever, not mathematically impossible. And notice, one more time, what we never did. We never opened the model. We made no claim about what it knows inside, no peek at a hidden answer. Everything you saw was behavior, possible futures, sampled from the outside. And yet from the outside we caught the moment of commitment, the very thing you'd assume you'd have to read its mind to find. So go back to where we started. When did the wrong answer become inevitable? The point was never the exact token. The point is that the question has an answer, that how reachable is the truth from here is something you can measure, watch, and see collapse. We've been listening to a machine think out loud and learning to see from the outside where it can still go. Because as these systems take longer horizon actions on our behalf, safety becomes the discipline of keeping good futures reachable, and you cannot keep open what you cannot see closing.